complicated of a figure, but for single wall carbon nanotubes, it turns out the story is about aggregation state. So this x-axis is the fractal dimension. So a fractal dimension of 1 is a single carbon nanotube by itself, and a fractal dimension of 3 is spherical, three-dimensional. So you can say 1D, 2D, 3D for this axis. And then this is how dispersed the aggregate sizes were. So did I have a single size dispersion, or were there multiple size dispersions? And you can see those things that were toxic are all these red ones, and the ones that were less toxic are these green ones. So they kind of form a cluster, depending on these aggregate properties. And our big question was, does this work going forward? So we took one of these green ones, and we manipulated its fractal dimension by changing its length. So it aggregated differently, and it went from being green to red. So at least as a first cut, from the 80-20 rule of, is this more or less toxic, I can start to manipulate these properties. So the goal here is really, can I figure out what functional properties of these nanomaterials are important for the application, intentionally I want them to be used, and then lead to implications like hazard or exposure that are unintentional, unintended consequences. So our goal is really to innovate this more sustainable tomorrow, and we want to do it by design. So we want to think about market, we want to think about the regulatory, the policy environment, the market environment. I'm going to stop there, and I will be happy to answer any questions that you have about this work or sustainability generally. Yeah.
What would be the biggest water contaminants?
The biggest water contaminants for drinking water? I mean, if you look at the EPA contaminant list for what a Safe Drinking Water Act is, there's hundreds and hundreds of chemicals on the list. So everything from inorganic to organic chemicals, disinfection byproduct is on there. There's a call to start regulating emerging contaminants like pharmaceuticals, right? So all this research going on, phthalates, bisphenol A. So there's the list that's legally required right now, and then there's this candidate list of things that people feel like need to be regulated but aren't yet. And EPA cycles through the old list all the time too to see if they need to ratchet down the standards if we have new health and toxicity. So I don't know if you have a specific contaminant that you're. Yeah, I mean, I think it's a good question. I mean, my gut instinct is that it has a lot to do with runoff, the stuff that's hard to regulate right now. So it's nitrogen and phosphorus running off from different land use changes because there's not a pipe and there's not something to say we can go regulate, but it's understanding how land use change around water sources affects the contamination that's flowing into the water. Yeah.
Have you looked at the mechanism or mechanisms involved in toxicity of arsenic-3 in humans and use that to, have you looked toward in that direction? Why is it more toxic, and could you potentially use that mechanism for as a removal system?
Yeah, that's a great question. So there was this really interesting paper that came out in Science about 5 years ago. Do you remember this, where they replaced arsenic for phosphate in DNA? And they had reported on, right, they look so similar in natural systems that they had actually substituted arsenic into the double helix, right, for the phosphate groups. So there's the cancer initiator concern is that arsenic looks like phosphate, which is something we use in our system all the time. Because arsenic-3 is uncharged, it passes through membranes very readily and doesn't get caught. And so it's able to substitute for phosphate, and that initiates tumor growth, is one of the ideas. So, I mean, could we think about doing something around charge screening? Yeah, it'd be interesting. We haven't kind of pursued that, but it's a really clever idea to say, how come that gets through and arsenic-5 doesn't? And can we design a system around that? I think that's a really neat idea.
How about it?
Thanks.